Good afternoon, distinguished participants. Ladies and gentlemen, my name is Ken Owanokwa. I'm here to give a presentation on monitoring wildlife collision. Since from the beginning of the conference, I've been here, and we have always talked about sustainability. Every sustainability is always geared towards human being. And now I want to look at the other smaller animals we are sharing our space with. The first is, if we look at wildlife collision, some of us who maybe, take for example, North Cyprus, may not be able to understand the risk of wildlife collision. In places like Germany, Australia, US, there is a lot of wildlife collision. It's up to 26,000 in a year, according to a study in US, and some of it will get up to 5.1% casualty. So that means it's something that should be taken seriously. And there have been so many devices that have been put in place, such as underpass, overpass, so that animals could pass over or pass under. But we'll find out that we cannot control these animals, their behavior. But sometimes it does reduce the risk. But we're trying to see if we could use an artificial intelligence to be able to maximize this risk and reduce it to the BRS minimum. First, we collected 25 variables, comprises of 21 animals, and then we have to add something like vehicles, like big trucks, small trucks, cars, SUVs, and vans, so that the network will, not just that the network will identify animals, so that the network will also be able to identify vehicles and not give a false prediction. Then the next is that we looked at how we were able to do the training. First, we collected the data, we sorted the data. Some of the data we collected were from Google image search, so that means we will have a lot of cleaning to do. And then the model, we use AlexNet and GoogleNet. Since AlexNet is using 227 by 227 and GoogleNet is using 224 by 224 pixels, so that means we have to do some image pre-processing. The laptop went off. So we did some image pre-processing so that we'll be able to get the image according to the standard of AlexNet. Another thing is that when you're using a deep learning, you discover that the images you will use there must not be less than 24 bits. 24-bit depth. If you have an 8-bit depth, which is probably black and white images, the network will, the algorithm will reject it.
Close everything. That's it. That's okay? Yeah, the battery later.
So after the modeling, we evaluated the results. Next, we look at the proposed architecture. You can see here there is an input. There is an input here. There is image processing. There is a model training. Now, we are looking at using an embedded camera system. The embedded camera system has been used in automated parking, whereby you have a car park, and then the camera will be able to detect the car park is free or is used. It's not just you just get into the car parking system and then you'll be looking for a free space. The camera will tell you, the system will tell you exactly where you are going to. So if we use this camera, then we'll be able to embed our software into it. And also, what the camera does is that it takes the picture and send it to, and then process it and send just the data to the central server. Then the central server, we are looking at integrating it into a image mapping system such as Google Map and Move It. If you travel a lot, you find out that when you go to some cities, you need some applications. So those applications, when you tell the application that you're going from this point to the other point, they will tell you the bus service, the traffic system, and the rest of them. Then we're now asking, why not we include this idea into this application, whereby if you're passing through areas where you have risk of wildlife collision, then if a camera detects it, it will be able to tell you that there is an animal coming, and it will be able to tell you the particular animal coming. For example, if a turtle is passing a road, you know it's going to take like 2 minutes to pass the road. If a lion is passing, then you won't worry about it because it's going to cross over. Then this is the architecture of the AlexNet. And the architecture of a GogoNet is quite big. It's about 145 layers, so we'll not be able to put it inside here. Then for the classification, we discovered that after the classification, we discovered that the deep learning was able to identify the images. Most of the, for example, if you look at here, for the trucks misclassification was between the SUVs and the big trucks because they have similar features. So the network couldn't recognize it, and also we have a lower data there. If we go up here, you will see that for the vehicles, we have like 200, 200, 200, 200. That makes it very, very difficult for the to have a very good training experience. Then when we come for the prediction here, you can see that the network was able to do quite well. It was able to identify tiger in as much as there is a noise background, a vehicle background behind. There is rhinos, there is bear. But for this bear here, it identified it as a mouse because of the posture of the bear. Then for here, you can see that it identifies as a big truck. Here, it identified as a tiger, elephant, snake, cow, rabbit, and rhinos also. There was supposed to be the Google Map simulation, which I did on Google Map, but my laptop doesn't have attachment to project it, so that's what I was supposed to show here. Thank you.
Yes. Okay. What you've done, you deserve a PhD. What you present. This is actually a PhD project.
Thank you.
Involves pattern recognition, image processing, artificial neural network, machine learning, motion detection. There's so much stuff there. Congratulations. Well,
thank you.
But can you explain a bit more about the model that you developed? How much of it did you develop? The software. There is AlexNet.
We use AlexNet and GogoNet. I try to use the higher versions of deep learning, but because I have my computer is not a supercomputer, the one I try to train, I trained it for 27 days. Unfortunately, at the 27th day, there was a up and down in electricity and everything went out. So if I have a super computer, I could go for VG16, VG19, which will give up to 97%, which I believe.
Yeah, the results look fancy and nice, but training deep learning, you use GPUs or CPUs? So
I use a CPU.
Because you don't have access to GPUs.
Yes.
But I'm curious about the software itself. Which model did you use?
No, we didn't embed the software because after the model, we are supposed to embed it into a camera, but one is this, we need a hardware to embed it, and probably we have to use MATLAB code transfer to be able to transfer it.
So which code did you use? Did you use any code?
Yeah, I use a MATLAB code.
MATLAB code?
Yes.
Didn't you know MATLAB had a toolbox for deep learning? It's Python and
Now, MATLAB has a code. For the two bus, you only use the two bus to check if your layers are correct. After you develop the two bus, then when you run the code, the two bus will now check if your layers are accurate. For example, AlexNet is about 25 layers, while GogoNet is about 145 layers, which is a huge, but it's a pre-trained network, so we don't actually edit all this thing. Editing all of them, you might run into difficulty. So
it's a very good topic. That's why I'm asking, and I'm, I know a bit about the topic. So where is the originality in the work here?
The originality in the work here is this. Take for example, in the paper which we reviewed, works were done in India. They only focus on the cow, and now you're going to put the camera on top of the vehicle, and that means it's only the vehicle that has the camera will be able to identify it. But we have a lot of street cameras everywhere, and we're not using them. We just use it to monitor the criminals, and then when we speed up. But what about the animals? If they are crossing, take for example, if a deer is crossing and there is a conservation camera within the area, it will take the picture and send the picture to the server. The server will be able to tell anybody within that area there is a deer around this area close to the road. From the Google Map, unfortunately, this other laptop doesn't have ports to project it. I tried to show it so that we'll be able to understand how it will work.
My last question. Can you put the network back to the deep learning network, which is how this one? Can
Yes.
you give us an idea about the layers?
Here is the input layer. You have to change your images to 227 by 227 pixels. So this is the input layer. This is the convolutional layer. You have the REL transfer. Then you have another layer there. You have the convolutional layer 1. It repeats in that order. Also, we have the drop layer in drop in 7. The essence of the drop layer is this. Since we're using stochastic training, and I'm using a mini batch, so it means that I'm going to be batching it. Because of the capacity of the computer, we have to increase the mini batch so that the training speed will increase. So that the network will not be picking the same image. So the drop factor is 50%. So sometimes it will drop some from the training, and in the next training it will include it and drop another one, so that it will not repeat those same images. So it's a stochastic training. So that means it could pick this one, it may not actually pick this one all through the whole training. Yes.
And your output is an image, isn't it?
Yes, is an image.
Well, after watching 2 days of this conference, I would say that the clear message of the conference is that human intelligence is not sufficient to solve the problem it creates. So it needs artificial intelligence.
Yes, sir.
Okay, we need artificial intelligence whatever we do. So what is the cost implications of what you suggest? This is very good, and then because I don't understand it, but suppose that I like the project, I would like to implement something. What cost are we talking about?
The cost implication starts first from the government policy. Take for example, most of these applications are not allowed in some countries. You come to a country, you want to move from one place to the other, it's only Google Map that is allowed. But the cost implication is quite low. It's just the companies that if Google decide to apply it, they will just integrate it into their system, but they will not need a right into all these street cameras so that the cameras will be giving them images.
Okay, well, law is not a cost. I don't mean what is not, but unfortunately what you suggest will not be applicable to Turkey. For those who can speak Turkish, it doesn't include Turkish magandas in the list of animals, so this is the most dangerous.
We only,
You have to be familiar with Turkish conditions. So that is a bad.
we can train any animal as long as we have the images. We can put into.
It's hard to get an image of the Turkish animal.
Okay,
Because you don't know when it's going to appear.
Which programming language were you using?
It was on MATLAB, MATLAB 2008A.
Okay. And which code for library or toolbox
No.
were you using?
I didn't use a toolbox. For now, deep learning is mainly on code. So you use code, but there is a part of the toolbox. You use the toolbox to check if your code is right.
AlexNet architecture was implemented in some way.
Yes, AlexNet was developed by.
What have you using to do this implementation? Tools.
I use AlexNet as an algorithm, as a training algorithm on the deep learning platform in MATLAB. The language is in MATLAB, not C or Python or the other one.
You a black box?
Yes,
Or it was open code and you
it's an open code, but most of the code you have to edit it to suit your.
I see.
Yeah.
This code, which library you have been using, from where you took it?
Oh, from MathWorks. I took from MathWorks and got. Sometimes I'll take from MathWorks and get. There is another library at GTOM or something like that. Merge two of them. If the MATLAB, the MathWorks is not enough, then I merge two of them so that I'll be able to get what I need. Yes.
Because I think that his question about the MATLAB toolbox was in some way about this tool. So if I understand well, you were using a mixture of many things.
Yes.